It is recording.
Okay, thanks.
So the data depot is where you can upload all the files that you want to use for your case study. And so I think that's pretty much it. Do you have any questions for the data depot?
So this is like where you have the storage for all input data. Is that correct?
Yes.
Okay. Yeah, I'm with you. Okay, go ahead.
Okay. So the next module is the workspace. So the workspace has all the apps that you need to run an optimization case study. So here is the general app workflow for at least for the case study that we used. So there are 3 different kinds of apps. There are data filters and file formatting apps, which would be, for example, see all of these 4 right here. Then there are distance finding apps, which would be these 4. These find distances between any 2 points, either by street or by railroad. And then you have the optimization, model, and visualization. So in this workflow, you would do things in order by the row. So you would do the first row of apps first, which is the first 3 right here. Then the second row, which is these 2. Then the third row, which are these 3. And then the 4th row and the 5th row. Now the apps in any row can be run in any order. So you can run this first, then this, or this first, then this and that, for example, although this one's optional. So I'll get started in explaining what each app does. So, for example, if you might want to start the whole thing with the KDF data filter. So you'd go over here and find the KDF data filter. So you have, here's the form for the app where you select all the parameters and inputs. And so this app filters the KDF billion ton data report for biomass supply. And so you have different parameters that you can select, such as the region, state, and in the boxes where it says please select one or more options, you can select multiple options or just one. Although the ones that say please select one option, you can only select one. So this allows you to filter by crop type, scenario, feedstock, year, and other parameters. So then after that you have job details, and there are 3 different parameters that are common to all of the apps. There's a maximum job runtime, and the maximum you can specify is 48 hours. But you can specify anything up to 48 hours. And so it will terminate after your maximum job runtime. And then you have the job name. So you can name the job whatever you want. And then the job output archive location, which is optional. So you can set this to set the output to any directory within your user directory. But by default, it will output to this directory, your user directory /archive /jobs / a folder with this format / a folder with this format. So after that, you click run, and then it will run the job, and then upon completion, you will go to the data depot, and then you will go to the location that you specified here, or otherwise you would go to the location that would be specified by the year, month, date, and the job name and job ID within your data depot in order to grab the output. Are there any questions so far?
So So the one that you have shown is just for KDF data filter.
Yes.
It's just for one, okay. And the next thing is so it's kind of a query, right? So you select these things and it populates based on the selection criteria.
Yes, yes. So this will filter the entire data set by the selection criteria.
So, and what is the for this development app? What is this? Do you use any kind of so this framework? Who is providing this framework?
What framework would that be?
Okay, so my question is, I guess, so this is a discovery workspace. So is it is it built in the E2SA, or you have to get it somewhere else? So this framework, like you put KDF filter and do all these things. So is it a kind of third-party software, or how do you?
You mean the entire portal itself?
Yeah, yeah.
So it started as a skeleton code by TAC. So TAC developed the DesignSafe research portal, which has a lot of the same things. And so they developed a skeleton portal that they wanted to provide to other researchers to be able to develop their own portals. And so they gave us the skeleton that they were, a work in progress skeleton that they were working on. And then we modified it for our purposes.
Okay. And is it in order to bring it, is it just a web link, or if they have like a certain type of like a source code type thing?
It's written in Django, the Django framework.
Okay. All right. Go ahead. Yeah, cool. Go ahead.
Then for see, the next example or the next app would be to run the counties, depots, and biorefineries filter. Now, for our case study, we were doing a logistics network from counties to depots to biorefineries. And the counties and depots were by street, and the depots to biorefineries were by railroad. And so you can go here, and you can filter by region. Right now it only has South Central, or by state. So what this does is we have data sets for all the counties in the U.S. All the depots are rail stations, so we have all the rail stations in the U.S. and then all the potential biorefineries in the U.S. And so you can filter out all three of those data sets by state, and then it will output new CSV files with the filtered output. Now, if you want to filter your own data, we have a general CSV filter app. So if you have your own biorefineries data set, for example, that you need to filter, you can go to this app, the general CSV filter, and you would, from your data depot, drag and drop the file to be filtered like that. And then you would enter the name of the column. So this can only filter by column values. So it selects the rows that match those values for that column. So you have to enter the name of the column you want to filter, let's say state. Then the values you want to filter, so, like Texas. And then whether it's a single value or a comma-separated list. So in this case, it would select single value. And then you can do that 2 more times if you wish, but you don't have to. You only need to specify one of these. And so that will filter out your data set by the column and the state. And so that's if you have a different data set than what we provide for our counties, depots, and biorefineries, or if you have a different kind of logistics network. So then next we have what I call the origin and destination CSV maker. So that is right here. And so for each arc in your logistics model, you have an origin and a destination coordinate, right? So this will take, so this assumes you have a data set for all your origin coordinates, and then another data set for all your destination coordinates. And so what you would do, so this app takes those and formats it into a format that can be used for the distance algorithms. So for this app, you would drag and drop the CSV file that contains the origin coordinates from your Data Depot browser over here. Then you drag and drop the CSV file that contains the destination coordinates. And then you have to manually enter the column number of the origin file that contains the identifier for each origin coordinate. And then you have to enter the column number that contains the latitude for each origin coordinate, and then the same for the longitude. And then you do that same thing again but for the destination coordinates.
So the manual is what are the intended for the manual? Is it what if you have multiple destinations, so you have to manually input each time?
No, so you create a CSV file that has all your destinations. And so you...
So I have origin and destination, so what is the purpose of manual input?
What was that?
So I have all the CSV file that has origin coordinate and destination coordinate.
Yes.
Then why I need to put manual input here? I was not able to catch that.
Well, you enter the CSV files here, but you have to run this app because it will output CSV files that are formatted specifically to find the distances. So it basically just takes those data sets and just formats them.
Okay, so it's the manual input is the file name type thing?
Yes.
Oh, okay. So basically you are saving the information to another file, and what is the file name? This is the purpose of manual input.
Can you explain what you mean by manual input?
So it is enter the column number of the origin file.
Oh,
that
yes.
Contains the ID.
Oh, yes. So that's if you have your column number. Well, this. So this formats it by filtering out deleting all the data except for the ID, latitude, and longitude, because those are that's the only relevant information for the distance algorithms, and it has to be formatted in a precise way. But for example, for our origin coordinates, we're using a county data set where it has the ID, latitude, longitude, and county name, and other things about the county, other irrelevant information. And so this filters out all the irrelevant information. So you enter the column that has the ID, latitude, and longitude, and then it creates another file that has only the IDs and the latitudes and longitudes of all the coordinates.
Okay.
So if your file is already formatted in that way, then you don't need to run this. But this is assuming a general file which has a lot of extraneous information.
Okay.
So then the next thing you run will depend on whether you need street distances or railroad distances. So I'll do railroad first. So you go to the railroad distances app. And this one is pretty simple. You just drag and drop the CSV file with the origin coordinates and the CSV file with the destination coordinates, and it will find the distances between each combination of origin and destination. Now, as I was saying before with the origin and destination CSV maker, you have to, if you have a general file with extraneous information, you have to run that the origin and destination files through here and use the output of this as the input to this. And so for this, I would recommend doing a maximum job run time of about 4 to 8 hours, just to be sure that it runs, because the program takes a long time to run. And so this will give you...
Is it the same thing that we had a chat like a few months ago that took a long time? Is it the same thing?
Yes.
Okay.
So this will give you two CSV files. One is a table of the distances between each pair of origin and destination coordinates, and the other is the same information but in matrix form.
So this railroad distance you're finding from third-party app, or you have your own embedded code here?
We're using a library in R.
Okay, so once you give this command, it will run this routine in the library?
Yes.
Okay. And how long does it take?
Depends on how many coordinates you have, but for the South Central region, it took about 20 hours or so.
Okay. So what if you run this information and save it, and then you just run from there, so that you don't have to run it again? Okay. Yeah, I got you. So go ahead. I'll let you move forward.
Okay. So next thing is, if you need street distances, the simplest way is to run OSRM full. There are different paths you can take, but for brevity, I'm only going to explain the simplest one. I plan on having a tutorial video on all the different street map distance apps and the different combinations you can do, and that will be up in the portal itself. But right now that might be a bit confusing, so I'll just keep it simple. We would run OSRM full to get the street distances. So for this, you need an OSM PBF map file. So that's an OpenStreetMap type file. So you can find these on the internet, for example. GeoFabric. I don't know if the website is working right now. There's a website called GeoFabric. That's spelled like that. That has a bunch of OpenStreetMap formatted map files. And so you download the osm.pbf file type, and then you would upload that to your data depot. And then when you go to the app, you would drag and drop that map file into this field. And then, just like in the Railroads app, you would drag and drop the CSV file for the origin coordinates and the CSV file for the destination coordinates. And same thing, it has to be formatted with the origin and destination CSV maker unless it's already in that format. And this one doesn't take quite as long to run, but it can still take several hours. Same as the Railroad Distances app, the output are two CSV files, one containing a table with each origin and destination and the distance between them, and a matrix with the same information but in a matrix format. So any questions so far?
No, good.
Okay. So then, once you've filtered all of the data and found all the distances between the arcs, then you can finally run the optimization model. So I'm going to use as an example, the optimization model app that we used for our case study. So, for example, we had to drag and drop the CSV file with county coordinates. These were filtered with this app earlier in the chain. Then you drag and drop the CSV file with the depot coordinates and the biorefinery coordinates, again, that were made with this app. Then you drag and drop the filtered KDF CSV file, which was made from this app. Then you drag and drop the CSV file with the street distances, which that one was output from the OSRM full app. Here you drag and drop the CSV file with the railroad distances, that was made with this app. And then the rest of the inputs are the parameters of the model. So number of scenarios, the demand, third-party cost, biorefinery investment, truck distance cost, train distance cost, and other parameters. And so this was specifically for the case study that we ran. So I have a general optimization model app already made. I just haven't uploaded it to the portal yet. So the general optimization model app will allow you to, instead of having a field for each and every parameter, there will be just one field where you can drag and drop a CSV file with all of your parameters. So, for example, you can make up new parameters if you need to, and so that will all be contained within that single file. So that will simplify the form. And then this will be generalized a bit here. So instead of calling these county, depot, biorefinery, we will have the user will have the ability to select 1, 2, or 3 arcs. So we can do up to 3 arcs in the logistics model. And so you'll have to drag and drop the CSV file with the origin coordinates for arc 1, the destination coordinates for arc 1, and then if you have a second arc, for example, you would there would be 2 other fields where you have to drag and drop the CSV file for the origin coordinates of arc 2, and then the CSV file with the destination coordinates for arc 2, and then same thing for arc 3. And then you will also have 3 distances fields. So you'll enter the distances for arc 1, and then if you have other arcs, you'll enter the distances for those. And then you'll have to specify whether they're street distances or railroad distances. And then I think that's basically it. So that's pretty generalized, again, to 1, 2, or 3 arcs, regardless of whether they're doing counties and depots or counties and biorefineries. It doesn't really matter. It's general. And so what it does in the background is it runs a Julia model with Cplex running through Julia. And so we also have a field to specify your Julia script that will run the model. And I think that's it for the optimization. Any questions on that?
Why you need to drag and drop? You can just tell an optimization model that where the file is located. Why?
You could, but drag and dropping does that. So here's where this is located, for example.
So this will help you to minimize so many manual operations. So what if you put the wrong file? So because if you know this is a comment. So for example, for optimization, so you have already generated some data through your previous app, like all this rail and etc. and all this app. Now in this form, what you could do is the new information. So what are the additional information is needed?
Mhm.
So help me understand what is the value of putting this drag and drop. So could it be bypassed, or why we need it to be here?
You mean because we've already generated all of these files from the other apps?
Yeah. All this file we have generated. So if I were you, I would just because it's a extra work. So what are the additional information? For example, enter base error. So this is a new information needed.
So yes, that's actually sort of what we're working on, but it's pretty difficult to do with the framework that we have. So this is actually what the workflow manager that as we call it, will be for. So this will basically have a diagram like this that looks very much like this, but it'll be interactive. So you can, for example, flag which apps you've ran and which you haven't ran. And you can also save the location of the data here, and then it will, when you run this, for example, it will use the data from here automatically instead of having you enter the file location into the field. And so we're working on that.
Okay, let me understand. So this is their workflow diagram, and can you modify it, or it shows the relationship, right? So
yes,
the dependency.
Yes.
So this drag and drop, is it mandatory if you want to implement this workflow, or anyway it is hard to modify this drag and drop?
It's pretty hard to modify. Also because we don't necessarily know the names of the files that would be output, for example. And then creating this also interactively also takes quite a bit of time. And so
you can, so because if you're a user, if you ask too many questions, then it's very hard to do. So one way is you can think of, it's just a suggestion, I understand you may miss some. So you can create some temporary variable which will lead to the file name. So each step, it doesn't matter if the file, it has different name or user. So you'll have to figure out some way in the optimization model, a temporary variable like in the button, and so it can be anything. User can put any file number, but optimization model can track those variables.
Mm-hmm.
Okay. Right. Okay. Go ahead. Yeah.
Right. Okay.
But you understand my comment is like
yes.
Because already you have do drag and drop, and you have so many information needed in this.
Yes.
Input files with optimization. So if you can minimize less information.
Yes, it definitely becomes a bit unwieldy. At this point.
Yeah.
But thanks for the suggestion. And yeah, we are currently working on something similar to what you were suggesting.
And my another suggestion is you see the railroad and OSRM, the distance. So instead of doing this computation, you can pre-populate the information. So you run all these things because once you know the destination, so it doesn't you have to run everything. So you can generate this data prior. So that if somebody wants to run optimization model in just different scenarios, so he doesn't have to recreate everything. For example, you are running a case study in South Central, right?
Yes. Yes.
And so all the distance, you know all the distance and everything. If already known, so you don't have to run this distance procedure again.
Right. 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 So you would only have to run these once, and then those files, the output, the distances are stored on your data depot. And so if you need those same distances to run another optimization model, you can just refer to those distances. So you don't need to run those twice.
Yes. Yes.
Correct. So then lastly is the KML generator. So this is to visualize your logistics network. So I guess first, the optimization model outputs a solution file. That it's a CPLEX solution file, and so once you have that, you will go to the KML generator. You will enter that solution file that you got from the optimization model, and then you have to enter your origin and destination coordinates again, and then that will use all that information to generate a KML file, which is basically a geographic information file. So it will output that to your data depot. And then you have three potential options of what to do with that. So first, KML runs on Google Earth, so it's a Google Earth type file. And so what you can do is you can go to your data depot. For example, if this was the KML file, you would just download it. You would download it to your local computer, and then import the KML file into a local instance of Google Earth running on your own computer, and then that will allow you to visualize the logistics network. The third option is to go to Tools, Visualization, and then go to Web, Google Earth. If you don't wish to install Google Earth on your local computer, then you can do it through Google's internet or online Google Earth. And there's an option somewhere in here to upload a KML file to the online program, and it will do this basically the same thing that your local version will do. Now the last option is I don't think it's quite working yet, but it's here. So we have an allocation on the Jetstream system. This is running a virtual machine with Google Earth running on it, and so this. I think only members of TSURI can use it at the moment, but we're trying to figure out how to open it up to the public. And so you would log in, and then it will show you a virtual machine running Google Earth, and then you can you can upload your KML file to that, and then visualize it on that. Now, the reason why we would go through this extra step instead of just the web page is because we're trying to figure out how to actually integrate this into the portal itself through a VNC session. And so we we already know we can't integrate Google Earth into our web page itself because the Google Earth API is deprecated. And so that's why we have Jetstream. But for now, I'd recommend either downloading the KML file and running it on your local Google Earth, or doing it through the Google's web page.
Do you have any demo right now that shows actual results?
Unfortunately, I can't at the moment because I don't have any KML files on my system.
Okay. So help me understand. So you generate all the results from optimization model. Now you want to visualize it, right?
Yes.
So why we need to? Can we bypass drag and drop so you can just run a button and shows what type of file you want to show?
Yes. Well, what we'll probably do is integrate this app into the optimization model itself. So the code that's running on this app can also run in the optimization model app after the optimization model completes, and then it will output both the solution file and the KML file. We created a separate one basically just for development purposes. But in the final general optimization model, we'll probably just output the KML automatically so that you don't have to go through this last step.
Okay. So what will be your typical, what are the things that you are planning to visualize here?
So it will visualize the locations of the coordinates that you specify and the optimal arcs in between them.
Basically, the supply chain network.
Yes, yes.
Okay.
I can email you a screenshot of the optimal the visualization for the optimal network that we found for our case study.
Sure. I would like to see it. Yeah.
Okay.
Yeah, this is all good stuff.
Thanks. So, any questions on the apps?
Yeah, I like the way that you find a complete framework, and so starting from gathering data, process data, then input to the optimization and visualization. So it could it's a good framework. And one thing that I can like you to focus on, minimize the user engagement. So if the user wants to put so much information, then it's not it's a burden for user. Also, the duplication of effort. So if you're generating data one time, so that you don't have to do it again. And also think of the visualization. So if you use any of the commercial softwares, for example, SAS, so you run some kind of some button and you just select what kind of figure you want. So it doesn't care about the output data from regression. For example, you have run a regression and you want certain type of figure, so it will show you what type of figure. So there is no extraction between the output. How do you figure the output? So it's already output. The output result already embedded with the figure. So say you want to generate a supply chain network. So it requires a certain type of input out data from the optimization model.
Right.
So you don't want to tell the user, okay, tell me which output data you want to use. So you kind of minimize those additional activities.
Right. Yeah. Okay. Yes. So yeah, and as I said, that's what we're trying to do with the workflow manager. And then the last thing The last thing that I want to show is the user guide. And so we have an overview of the steps that I showed. For example, data preparation, finding the distances, optimization, and visualization. You have a pages that explains the purpose of all of these modules here. Then you have an apps tab that explains what each of the apps does. We have video tutorials. So tutorials 1, 2, 3, and 4 go through our case study. And then I also have a tutorial on how to make Agave apps, which would be, for example, how to make these apps here that show up in the workspace. So we could have users create their own Agave apps and then submit them to us to upload to the portal. And then soon we will have an explanation of the case study. And then we also have this about page where you are listed here. And that's it.
Yeah, cool stuff. Thanks, Mario. Good work.
Thanks.
So are you're about to graduate?
I already graduated in December. I'm about to move to a new job.
Ah, okay. Congratulations. Where you are moving?
Well, I already graduated, so I was looking for a job in industry.
Ah, okay.
Mm-hmm.
All right. So yeah, I like the way you put it together, and it's good.
Thanks.
All right. Thanks, Mario. I appreciate it.
All right. Send me your username if you haven't already, and soon I should be able to add you to the system so you can see everything on your with your login.
Okay, I'll do that.
Okay. Thanks.
Thanks.
All right. Have a good day.
You too. Have a nice weekend.